Okay, I'd like with you to do, this is one of your homework problems, so feel free to follow along with me, and there'll be one fewer homework problem that you have to do. But we're gonna do page 661, number 48. Now, if you have not read this problem first, do, right? If you're just going to look at me for this. As a matter of fact, if I were you, what I would do right now is I would pause this video, read the problem, and try and set up your knowns and unknowns. What this says is a negative 5.5 diopter lens. Well, real quick. The equations we've talked about, right, are the thin lens equation, 1 over di plus 1 over do equals 1 over f, and magnification equals hi over ho equals negative di over do. And I guess there's one equation I forgot to bring up with you in the video that you watched in class, and that is a lot of times, just for simplicity, we define the power of a lens as 1 divided by the focal length. And power is measured in diopters, capital D, which is just a fancy way of saying inverse meters. Okay, so let's look at this. It says a negative 5.5 diopter lens. So that means that my power is negative 5.5 diopters. Is held 14 centimeters from an object. So the lens is 14 centimeters from the object. So that means that the DO between the lens and the object is 14.0 centimeters. That is 4 millimeters high. So the height of the object is 4 millimeters. And the question is position. What is the position, type, and height of the image? So really what I want to know is the image distance, and this will tell us what type it is. And I want to know the image height. So those are my knowns and unknowns. I'm going to draw a sketch here just to kind of get our mind around what this is doing. So I'm basically going to freehand what's the word I'm looking for? One of these things, a ray tracing diagram. So what I'm going to do is, this power is negative 5.5 diopter. Now power isn't helpful to us. We have to use focal length in this equation. So let's find what the focal length is. If power is 1 over the focal length, then that means focal length is 1 over power. So it's the inverse of 5.5. So I'm getting a focal length of 0.18, and you can't see that. I'm getting 0.18 meters, so that's 18 centimeters. Negative 18 centimeters, because this is a negative diopter. What does negative focal length mean? Well, remember in our notes we said negative focal length means it's a diverging lens. So I'm going to draw myself a diverging lens here, which kind of looks like that. And I'm going to draw an object of some kind that is located 14 centimeters away and has a height of 4 millimeters. Just to get common units, let's call that 0.4 centimeters. All right, now we want to find di and hi. So let's try this equation. If we do 1 over di equals 1 over di plus 1 over do equals 1 over f, then we've got 1 over di, which is what I don't know, plus 1 over do, which is 14 centimeters. As long as everything's in the same unit, you don't have to convert. So 1 over 14 centimeters equals 1 over negative 18 centimeters. So 1 over di, if I subtract 1 over 14 from both sides, you can get a common denominator. I'm going to just use my calculator and say, okay, what's 1 over negative 18 minus 1 over 14? And you get negative 0.126 0.98. That's 1 over di, so then di is the inverse of this, right? Di is going to be 1 over that. Which I'm getting that the image is negative, the image is negative 7.87 centimeters. What does that mean? Well, that means we answered what di is. It also means when di is negative, what kind of image is it? When di is negative, it's a virtual image. So we've answered another question. This is a virtual image because di is negative. And then the last question is, what's hi? Well, we've got this magnification equation here. So we can use any two parts of this magnification equation. So I'm going to say hi over ho equals negative di over do. So in that case, hi should equal what? Negative ho times di divided by do. If I just cross multiply there and divide. So it's what? Negative ho was 4 millimeters, which we converted to 0.4 centimeters, times the di we just found to be 7.87 centimeters, divided by do was 14 centimeters. Oh, careful, this is a negative 7.87. So it's going to come out with a positive magnification. So I'm getting 0.22 centimeters, which is the same as 2.2 millimeters, is the height of the image. There you go. That's how to use all the equations.